We have a mesh circuit here, and a voltage source is connected through a resistor to a series combination of diodes. Each diode is characterized by this I-U relationship. So at first we have to find the total I-U relationship of this combination, and then we may apply piecewise linear approximation based method. We have these two elements connected in series, which means that we have to add voltages for the same current. At this breaking point we have current of 1 milliamp, and we have to add these voltages, and the obtained total characteristic of this combination is presented at the right. The breaking point now is at 1 milliamp and 1.4 volt. The first segment can be modeled by a resistor 1.4 kilo ohm resistor, the second segment by an ideal voltage source 1.4 volt. If we assume at first that our Q point is located on the second segment, we may find mesh current, and this mesh current is greater than 1 milliamp, which means that our assumption was correct, and this current is 1.4 as calculated. We may verify this calculation by means of PSpice. PSpice netlist version is below. We have a netlist for this simple circuit. I'm not going to discuss this netlist. This is a probe window. As we can see, a breaking point for this circuit is at 2.4 volt. We are changing this input voltage from 1 to 4, and at 2.4 we have a breaking point. Below, these two elements are replaced by a resistor, and above by a voltage source as we have calculated before. 1.4 kilo ohm resistor and 1.4 volt voltage source. And now same circuit, but a practical model of diode. We may compare the results, PSpice simulation, and as we can see, there is a slight difference. Now we have at this point 1355 milliamp. Before then, for an let's say ideal characteristic of diode, piecewise linear characteristic of diode, we have had 1.4 milliamp. Same circuit, but different input voltage. We have already performed calculations or simulation, so now we may assume that our combination can be replaced by 1.4 kilo ohm resistor, and this assumption is correct, and current is 0.5 milliamp. Once again, on the same plot, we may see this is now a Q point for 1.2 volt input voltage. And finally, let me consider nearly the same circuit. The only difference is that now we have a combination, a parallel combination of these two diodes. So now we have the same voltage, and we have to add currents. So at the breaking point we have to add currents. At this point we have to add 1 milliamp to 1 milliamp to obtain 2 milliamp. Now breaking point of this combination is 2 milliamp, 0.7 volt. This segment can be modeled by 350 ohm resistor, and the second segment by 0.7 volt voltage, ideal voltage source. If we start with this assumption that the Q point is located on the first segment, we will find that our current is exactly 2 milliamp, which means that our solution, our assumption is correct, and this is our solution. 2 milliamp is a mesh current for this circuit.